as A, B, C, D, E, F presents the similar shape characteristic with the same plane development, rectangular plane development, and the same dimensions, similar dimensions, based on a visual analysis. The dimensions are the width 15 centimeters, the longest side are 25 centimeters, and the height 20 centimeters. And they present many kind of motifs of decorations, such as Saint-Andrew crosses, grid pattern, swastikas, etc. And based on these motifs, we can assign the models at the subgeometric period and date back to the 6th century before Christ. If we analyze the A and F models, we can see that there is a representation of timber structure. These are models that represent temple, an huts, or in general an house. And the timber frame is characterized in the model A by 3 frames with similar spans, and also in the F models. And these frames have the characteristics that are stiffnessed by the presence of the diagonal. These diagonal are present also in the roof. Yes, the other thing that it's worth to observing is that the load bearing structure is raised from the ground. Perhaps this is a durability device, a technological device, because in this way there is no direct contact with the ground, with an high humid environment, with an environment that generates biotic attack. In the 2 extremities, there is represented a proto-truss, a king post truss. We can see that it's completely in all its elements, such as the type beam that you're after, and is devoid only by the struts. And in the model F, we have also in the type beam these particular motifs, this particular decoration, that these are an alternative empty and full parts that remind us to a ceiling composed by beams, and these beams running parallel to the longest side. So this is an arrangement that is not there is not an optimized structural behavior. The model B has the particularity that all the members and the wooden members are characterized by a rounded shape. Perhaps the wooden elements are raised, are put inside with the bark or just unbarked, and presents also a secondary structure that is perpendicular to the ridge beam. It's evident also the presence of a king post truss with a type beam that have the resistance section higher than the other elements of the trusses. There is also the presence of, also in this case, of diagonals. So it's a fascinating hypothesis to think about this, about a research of an anti-seismic behavior of the building, a research of an anti-seismic behavior. But we are sure that it means an improvement of the stiffness, a limitation of the deformability of the frame. Also, the grid pattern in the longest side has the similar aim, because the transversal and the post that is arranged near to each other means an improvement of stiffness under horizontal action. The roof presents also an high inclination, that is a strange thing, because in our geographic area, for climatic reason, we have always a roof with a low angle. In this case, the presence of an inclination permits an effective of the joint, because there is a low component, horizontal component, and this horizontal component ensure to the joint an effectiveness, and also this horizontal component means a low tension on the type B, a low tension parallel to the grain in the type B. This is a particular detail of the prototruss. All the joints are characterized by ropes, and so in a certain way these ropes ensure a two-dimensional behavior under horizontal action, for example, under seism. This is a different behavior of modern and pre-modern trusses that transmit all the force by means of pressure, our gravity joint. In this case, the ropes that fasten the joint allow a three-dimensional behavior in a certain way. This is the dimensional survey of the B model, and there is a virtual reconstruction. The weight, that is a low weight because we have attached the roof, is discharged in the four supports, the four quadrangular supports. Another figure that emphasizes the timber skeleton. So there is another thing to observe, because the executor of the model is a sharp observer, because he, from the reality, has noticed many elements, has represented many elements, and also has represented some deformation, such as in the tail beam. We have a subsiding of the tail beam with a rotation, and this rotation generates an inflection of the diagonal. So perhaps this is the first representation of instability, first of Leonardo, first of Muschenberg, first of Eulero. This is generated thank you to the solidarity of the timber structure that in all situations the timber structure is characterized by structural solidarity. Another element that reminds us to deformation is the ridge beam, where there is the representation of elastic and creep deformation. In this case, is represented in a proper way with a concave rotation in the midpoint of the beam. So I'm going to conclude. These models represent construction. So they are an important document to understand the development, the history development of timber structure in Austrian culture and in the Europe in general. Even if it's worth to considering that we have to read these models, keep in account some caution, such as the possibility that the realizator of the executor of the model can represent some holy symbolism, and also there are also other limitations that are, for example, that the material is not easy workable. So if we keep in account this limitation, we can read this model as a construction